Today we're tackling a really big one, something straight out of the movies, almost. Time travel.
Oh, yeah, definitely. You think Back to the Future, right?
Yeah,
Or Interstellar with all its craziness, even Avengers, Endgame, it's everywhere in fiction.
absolutely. We've all seen it on screen. But here's the thing I always wonder, and maybe you do too. Could it, actually be real, beyond the special effects?
That's the million-dollar question, isn't it? And, well, what's fascinating is that actual physics, real science, suggests some parts of it might not be total fantasy.
Okay, because when I think time travel, I'm picturing, flashing lights, maybe a weird machine. It just feels so fictional.
Totally understandable. I mean, that's our main reference point, right? These amazing stories. But theoretical physics has genuinely, seriously considered this stuff. It's moved past just being a cool idea.
And usually, when you dig into the science side, one name keeps popping up. Albert Einstein. He's kind of the key figure here, isn't he?
Oh, absolutely central. Yeah. Einstein's work completely changed how we think about time itself, how it's woven into, well, the universe. He basically showed us time isn't some rigid clock ticking the same everywhere for everyone.
Okay, hang on. Einstein said time is not absolute.
Yeah.
What does that actually mean, though? In simple terms, it sounds pretty out there.
Right, it does. Think of it like this. If two people watch the same event, say fireworks, but from different places or moving differently, Einstein showed they might genuinely disagree on the exact moment things happened. Time isn't universal. It's relative, flexible. That's the core of his theory of relativity.
The theory of relativity. Okay, so how do things like speed or gravity mess with time, according to this theory?
Well, basically, the theory predicts that the faster you move through space or the stronger the gravity you're experiencing, the slower time passes for you compared to someone, say, standing still or in weaker gravity. We call that time dilation.
Time dilation. So wait, if I was on a super fast spaceship, like really fast, my watch would literally tick slower than yours back here on Earth.
Exactly that, yeah. And the effect gets much, much stronger the closer you get to the speed of light. You could hypothetically travel near light speed for what feels like a few days to you, and decades could pass back on Earth. It's pretty mind-bending.
That is absolutely wild. But is that just, a cool thought experiment, or is there actual proof that time does this stretching and squeezing thing?
Oh, it's definitely been proven. We have solid evidence. A really good practical example is actually the GPS system, the satellites orbiting Earth.
GPS. How does that work?
Well, those satellites are moving really fast, much faster than us on the ground, and they're also further away from Earth's gravity, so gravity's pull on them is slightly weaker.
Okay.
Because of both those effects, predicted by relativity, the super precise atomic clocks on board those satellites actually run a tiny bit faster than identical clocks down here on Earth.
Wait, seriously. Their clocks tick faster.
Yes, by a very small amount, like fractions of a second per day. But GPS needs extreme accuracy, right? So if engineers didn't constantly adjust for this time difference using Einstein's equations, your GPS map would drift off course pretty quickly, by miles even.
No way. So the fact we have to correct for it proves time is actually different up there. It's not just theoretical math, it's real-world tech.
Exactly. It's a direct, practical application of relativity. And, well, that difference in time passing means those satellites are effectively traveling into the future relative to us, just by a tiny, tiny bit.
Wow.
So future time travel in these very small increments, it's real, it's proven, it happens constantly above our heads.
Okay, my mind is officially blown. Future travel checks, science says yes, even if it's small hops. But what about the Back to the Future stuff? Going backwards.
Ah, right. Now we're getting into much more speculative, theoretical ground. One big idea that gets talked about for past travel involves something called wormholes.
Wormholes, yeah, I've heard of those. Aren't they supposed to be like cosmic tunnels or shortcuts through space?
That's a pretty good way to picture them. Yeah. Imagine a tunnel connecting two very distant points in space-time. And space-time is the key word there, not just different places, but potentially different times.
So you could, step into a wormhole here and now and maybe step out yesterday? That sounds like pure sci-fi.
Well, that's the theoretical possibility, yes. But, and this is a really, really big but, we have zero actual evidence that wormholes exist. None.
Oh.
And even if they do exist somewhere, we have basically no idea how they'd form, how we could possibly create one, how we'd keep it stable, they'd probably collapse instantly, or how we could travel through it safely. It's purely theoretical at this stage.
Okay, so wormholes are a massive question mark. But say we magically found one.
Mm-hmm.
Are there other problems with going back in time? like logical ones.
Oh, big time. Yes. The most famous one is probably the grandfather
The
paradox.
grandfather paradox. Yeah, yeah, I think I know this one. That's where, like, if you went back and stopped your own grandfather from meeting your grandmother.
Exactly.
Yeah.
Then you wouldn't have been born. But if you weren't born, you couldn't have gone back in time to stop them in the first place. See the problem? It creates this impossible logical loop, a paradox. It makes you seriously wonder if the universe just fundamentally prevents that kind of thing.
Okay, okay. So let me try and sum this up.
Yeah.
Going to the future that's actually real, scientifically proven because of relativity, like with the GPS satellites,
Yeah.
even if it's tiny amounts.
Correct. Yeah.
But going into the past, that's still just an idea, maybe possible with things like wormholes,
Hmm.
but we don't know if they're real. And you've got these huge logical problems like the grandfather paradox.
That's a perfect summary. You've got it. Future travel is a real observed phenomenon. Past travel is, well, it's highly speculative, fascinating, but faces enormous theoretical and practical hurdles. We're nowhere near building a DeLorean, basically.
It's still just amazing to think that science is even asking these questions, really digging into what time is and if we could ever manipulate it.
It really is incredible, isn't it? It just shows that deep curiosity we have, trying to figure out the universe and how it all works.
And, thinking about all this, maybe the most real kind of time travel we have access to right now is just trying to be fully present, right here, right now.
That's actually a really beautiful way to put it. Yeah. Maybe fully experiencing the present moment is its own powerful way of navigating time.
Well, thank you for diving into this absolutely mind-bending topic with me. My head's spinning a bit, but in a good way.
Oh, my pleasure. It's always fun to talk about this stuff. It really stretches the imagination, doesn't it?
It really does. And thank you all for joining us for this deep dive. We'll catch you on the next one.